So in this video and in this collaboratory notebook, we're going to show how you can extract some data from a website and then visualize that data in a figure. So we're going to start, we're going to extract some data from this Dortmund database website. In order to analyze and visualize this data shown here related to the water vapor liquid equilibrium. And then in a separate video later, we will put the parameters of the Antoine equation to this data. So first we're going to start with the basic functions in our collaboratory notebook. We'll start by typing from LXML, which is a Python library, and then we're going to import HTML, which is going to allow us to use the Dortmund database website. Enter, and we import requests. And this module is going to allow us to request the content from the website. We import JAX, which is another Python library that automatically does derivatives and a lot of other functions that we'll need for the Antoine equation later. And just defining JAX, JNP. Then we import numpy as np, which is a basic Python library. And then we're going to pull from SciPy, which is an open source software for mathematics, science, and engineering. By typing from SciPy optimize, this is going to allow us to minimize scalar functions, which we'll need later on. So we type from SciPy.optimize import minimize. And then now we're typing from plotly dot subplots import make subplots. And that's going to allow us to be able to plot and visualize the data we extract. And then from plotly import plotly.io as PIO. And this function contains various image export settings, and it'll allow us to manipulate those settings when we're configuring our figure later on. And then we want to pull from collections, another Python library, and import the queue function, which will give us the objects in the Dortmund database website in a list form. And then lastly, we want to type PIO templates.default equals plotly dark. And that's just going to allow the figure we make later to contrast the white background we have here in collaboratory, which is not necessary, but helps. And then for later on, when making the figure, we want to type from jax.config and then import config, and then the following function. Config.update allows us to enable part of Jack's, we want a 64-bit, which gives us double precision when we're configuring the data. Type true to enable that. Okay. Okay, now so we are ready to copy and paste the URL and bring that into our collaboratory notebook. So I'm going to go to the Dortmund Databank website, copy that URL, and then here we type URL equals, and then I'll paste that. And then we want to request the content from this website. So I type content equals request. And we're allowed to do this based off this module we imported here. Then get URL dot content. And here we're just typing tree equals HTML from string content. Okay, so now we can actually extract the data from the website. So I'm going to go to the website, and we can pick any data point here and actually copy and paste a XPath. So we'll right click, hit inspect, and then I'll right click again on this exact data point, copy XPath. Go back to my collaboratory notebook. And so now we have the XPath string. Now I'll type T strings equals tree dot XPath, which is what we defined right here, and that's going to bring the content from the XPath of the Dortmund Databank website. And then we're going to paste that XPath into here. And we're going to go ahead and do the same for the pressure. The T string is going to be the temperature string, and then here is the pressure. Same thing, paste. Now this XPath gives the exact location of this data point here, but we want the whole temperature and pressure columns. So we will take out the row, the table row, for both the temperature and pressure strings, so that it will include the entire column and all of its contents. And then since the temperature is in the first column, we'll type 1 here, and then we have 2 here. Now, since we want the text from the table, we want the actual data, we'll type slash text. Okay, and then same for the temperature. We want the text. Okay, so now we have the XPath for all these data values in the temperature column and the pressure column. So now to organize the data we've just extracted, we type data equals np array, and then we enter the parameters for the temperature strings we just brought in. as type float 64. And this 64 we are allowed to use because we enabled the JAX 64-bit, which is going to give us double precision. We shift enter. Oh, I did not put plural on the strings up here. Strings, enter. Okay, so now we have organized the data. We're going to set the parameters for the array that we have just defined here. So T equals data starting at 0. Log base 10 P pressure vapor pressure equals NP log base 10, and then since the values given here are in kilopascals, we're just going to multiply it by the data by 1000 here to get it to pascals. Data. Okay, so now we've set the parameters for the array of data we have defined right here, and now we are ready to configure our plot. So we start with fig equals make subplot. Rows equals 1, columns equals 1. Enter. Then we want to add the scatter plot. Define x is t, and y is going to equal that log base 10 of the vapor pressure. And then we want the data to show up in markers. So we do mode equals quotation markers. And we define the marker size equals 8. Marker color. And this can all be changed to however you want your figure to look. Let's start with this. Go ahead and enter so we can see this clearly. The marker line color. Then we can change the width of the line. Set it to 1. And then we'll name this scatter data as our data. Okay. Go ahead and enter here so we can see everything clearly. All right. And then we want to type fig.update, and this is going to allow us to manipulate the layout of the figure. We can change the width. We'll make it 100. And we can change the height 500. And then again, updating the layout of the figure we're creating. We want to give the axes some titles. So we'll type x-axis, title, and that is going to be our temperature in kelvins. And then the y-axis is going to be our vapor pressure in pascals. And then we want to show. We hit Shift Enter, and here we have our plot.